Yours.
Yeah, thank you very much. So my name is Burkhard Noltensmeyer. I will talk about our small project of IoT data aggregation of a wind farm. Usually we use Prometheus and Kubernetes in our infrastructure, so we are a managed service provider and running Kubernetes clusters for our customers. And as such, we were working with a customer in our region. It's the Paderborn region. And they operate 100 wind turbines, and they use Siemens SCADA system for controlling these wind turbines. Unfortunately, these Siemens systems has got very weak capabilities regarding reporting and data science and statistical analysis. And so that, we provided proof of concept to our customer, and we talked to them and asked them, so why not use Prometheus for monitoring of your performance data of wind turbines? And they use Enercon wind turbines, and they have got an interface OPC XML DA. And this is a somewhat ancient interface, but fortunately there was a Python library available in the internet. It's PyOPC 0.1, the newest release from 2006. So it's a kind of ancient release, but we managed to write a Prometheus exporter and have several metrics that we export, and we annotate these plants with the region, the wind turbine, and their type, as you can see here, for example. And we have several other metrics that we export, like temperature and yaw, the direction of the wind turbine. And we also need a means of running our Prometheus exporter, and we resolved to an industrial Raspberry Pi. This is from a company named Kunbus. It's a very nice system. And we set up cloud native technologies for data acquisition inside the wiring cabinet with this. And as I mentioned, we choose Prometheus for its powerful query language and its efficient design. But Prometheus also has got some shortcomings. It has got no redundancy, no data retention, no multi-tenancy, and but there are certain open source projects to circumvent these limitations. So we use the Thanos project, for running Prometheus in a redundant fashion and to be able to have long-term data retention. And we use in front a reverse proxy, a key cloak, a gatekeeper for having OpenID Connect authentication. And for visualizing the data, we resolve to Grafana, which you may already know. And for specific analysis, we use Jupyter notebooks, and Jupyter notebooks are very popular in the data science domain. They contain both the code and the representation of the data. And so if you need special analysis, you may use Jupyter notebooks. And I might give you an example. And let's see. So I've got a Prometheus dashboard here, and I can choose a metric like, for instance, max wind speed. And this is actual data up to the moment. So I can do the graph representation. Now we've got here, it's 1 hour back because it's UTC. And here you can see the wind speed for the last hours. We may take a little more, like 50 hours. So, and here you can see there's a storm on Sunday. And so these are all wind turbines, but we might only be interested in the maximum speed here. And this is 40 meters per second. And if we multiply this by 3.6, then we have kilometers per hour. So on a Sunday afternoon, there were 140 kilometers per hour in the wind turbine, so at the height of 120 meters. So this is quite something, I would say. And another example might be the yaw, that is the direction of the wind turbine. Here you can see there are different bands, so the turbine can turn multiple times. So the angle can be maybe 700 degrees, but not 340 degrees. And to resolve this problem, we can put the wind turbine 2 rounds, 2 times 360 forward. Then we have got a positive angle, and then we can do like a modulo 360. And then we've got all the angles normalized, and then we've got a few wind turbines which reports 0 degrees, and we can filter that out also. Now we've got sanitized data that we can work it, that we may do alarming on it. And also Prometheus has got the availability of doing consolidation. For instance, we have a region label, each wind park, and they've got 4 wind parks, and now we've got the consolidation of the yaw of the nacelle per region. So this is the powerful Prometheus query interface for ad hoc queries. And we also set up dashboards in Grafana. As you here see, this is a region dashboard. We've got 2 regions here. And unfortunately, the power grid in Germany is not strong enough to cope with the renewable energy. And the yellow curve here is the desired cap from the network operator. So here, the network operator gives them the signal. You may only put 6 megawatt into our network, and then the wind turbines are automatically scaled down. And the green line is the actual line that is scaled down to. So here you can see your lost money, or the wind park operator can see it's lost money because he's forced to scale down the system. And here's another difference between produced and exported energy. So there are some losses between the energies, between the wind turbines and the transformator in the wind park. And this is in the region of 1 or 2% that you can see here. And here are the amount of wind turbines that are in an operational state. So this is what we worked out with our customer. And one example with Jupyter notebooks. So here are certain notebooks. This is the Jupyter interface. And then you can choose a notebook and run this notebook. And this is an example for the notebook. This data is extracted from Prometheus. So here you can choose a region, and you can choose maybe a plant in this region, and then the power curve from the plant is displayed. It's a 2-dimensional graph. On the y-axis you can see the power, and on the x-axis you can see the wind speed. And this line is when the wind turbine is power capped, so it can only produce 1 megawatt regarding the wind speed. And here, with this high wind speeds, the power is 0 because at storm it will turn off automatically. And we may take a small glimpse into the code. What you can see here, we use the Plotly library in Python and widget library. And we then do an init diagram. And what might be interesting is here, this is the query string that we get the regions from Prometheus, and then the plants. And then here are another 2 strings to get the amount of power and the wind speed. And then we can do the plot. So it's rather straightforward. And then you get these nice plots in Prometheus to get, in Jupyter, to get a visualization of your data. Yeah, okay. I might continue with my presentation. So this I already showed to you. Here's another diagram. It's a 3-dimensional diagram in Grafana. So we've got the wind speed, the direction, and the time. So the color is symbolizing the time, the last 6 hours. So you get a glimpse what the wind speed and the direction was. So, and learn from data. That's what we saw, the performance curve, outliers, examine exact effects of a storm, and define alert rules to have certain alerts. And this is the resulting architecture that we run in a Kubernetes cluster. So we've got a microservice architecture. We run Prometheus as a foundation together with the Thanos project. And then we also provide Grafana and Jupyter Hub and have an OpenID Connect authentication to combine all the different elements of this architecture. So what OpenID Connect enables is you can do some kind of access token forwarding. So you get an access token from the login, and then you can reuse this access token to authenticate against another microservice to maintain the user identity. So this is me on the wind turbine. I'm looking a little bit concerned. It's 120 meters, so it's quite impressive to be up there. Yeah, thank you very much. So I'm at the end of my presentation. We've got nice cups here at the booth. You can get one with this deco. And if you've got questions regarding our data science projects, I will be there at the booth and answering your questions in more detail. So I'm finished now. Thank you very much.